All right, we're finding probabilities of normal distribution. This is section 5.2. First of all, we have to look at this formula right here. This is how you find your z-score. X is a value that you're trying to find a probability of, where this is mu, the mean, and then this is sigma down here. That's your standard deviation. So z equals x minus mu, all divided by sigma. All right, what does that mean? Well, here's an example. Sam shoots 10 free throws every morning. On average, he makes 7 with a standard deviation of 2. All right, so on average, 7, that means my mu is 7, and right here my standard deviation is 2. Now what this means is he averages 7, so if I do 7 minus 2, that would be 5. And then 7 plus 2 is 9. Generally, he makes 5 to 9. From 5 to 9 is generally what he makes because of his standard deviation of 2. So if I subtract it, 5, add them, 9. That's generally what he does. Okay. Well, what's the probability that Sam makes less than 4? Okay, well, to do this, we're going to have to convert that into a z-score by doing this right here. Again, I'll write it down here. Z equals x minus mu divided by sigma. So my z-score for this is going to be my x value, which is 4 in this case, minus my mu, which is 7, then divided by my standard deviation, which we said was 2. This was from up here. Okay, mu is 7 and standard deviation is 2. So I just put those in and I just calculate that with my calculator here. So 4 minus 7 and then divide by 2. That's negative 1.5. So my z-score is negative 1.5. That's my z-score for this. Now, all I do is I get my z-score table and I look this value up, negative 1.5. Negative 1.50 is right there. 0.0668. So this is his probability that he makes less than 4. If he's on average making 7, then this is if you move it over 2 places, that's 6.68%. It's a 6% chance he makes less than 4. Okay. Well, what about this? And again, I didn't point this out, but on the table here, see these z-score values, that's the area, these probabilities is the area less than that value, which is what we were wanting here, less than 4. But now right here, it's asking what's the probability that Sam makes more than 8? Okay. So I got to find my z-score. So z equals, this time my x is 8, minus my mean, which we said was 7, divided by the standard deviation, which we said was 2. So I punch this in the calculator. 8 minus 7 would be 1. 1 divided by 2 is 1/2. So that's 0.5. There's my z-score. Okay, so I looked that up on the table. All right, now, so 0.5, that's on the positive one. 0.5 is right there, 0.6915. So this is from the table, okay? But this value right here now is to the left. If you look at the, see, this is to the left. This says he makes more than 8, which means that would be to the right. So that means I'm going to do 1 minus this. I'm going to do 1 minus 0.6915. which would be 0.3085. And that would be his probability of doing that. Okay. In the third kind of case we would have, what's the probability that Sam makes between 6 and 9? Between 6 and 9, what's his probability of doing that? I'd say it's pretty high. But here we got to find a z-score of both of these. So my z-score of 6 is 6 minus 7 divided by 2, which is negative 0.5. So there's my z-score for that one. And then 9, I'll do 9, so z, that'd be 9 minus 7 divided by 2, which is 1. So there's my two z-scores. And so I look both of these up. So negative 0.5, okay, negative 0.5, it's right there, 0.3085, 0.3085. Now 1 is right here, 0.8413. See right there, 0.8413. And then I subtract these two. So 0.8413 subtract 0.3085. So this is going to be a 8, this is going to be a 2, 3, and there you go, 0.5328. So that's the probability he makes between 6 and 9. Okay. Let's look at some of these problems that we're dealing with here. Like this is number 1. I'm going to do a few of these. I'm going to skip around some. We'll do all 3 of these here. Assume random variable x is normally distributed with mean, here's my mean right there, and a standard deviation right there is my standard deviation. Find the indicated probability. What's the probability that it's less than 85? Okay, that's my x. So I got to find my z-score. So my z-score is going to be that 85 minus this 88 divided by 4. That would be my z-score. Okay? Remember, this is it right here. You got to do your x minus your mu divided by your standard deviation, which is what I did right here. Okay, so I punched that in. All right. So I go 85 minus 88. That's negative 3, and then divide by 4, and that's negative 0.75. So this is going to be negative 0.75. This is my z-score. Okay, that was my z. Now I look that up to see what the probability is. So, oh, it's negative. I didn't put my negative in there. Okay, so it's on the negative one. Negative 0.75, so negative 0.7, and then 0, 1, 2, 3, 4, 5, 0.2266. See it right there, 0.2266. Okay, and that's the probability. See, again, on these z-scores, these are my z-scores outside here, and inside here, all these numbers inside are the probabilities for these z-scores outside. Okay, let's do number 2. Assume the random variable x normally distributed with the mean. There's my mean, and here's my standard deviation. Find the indicated probability. All right, what's the probability that x is greater than 41? All right, greater than, which means the table is less than, so I'm going to have to subtract it from 1 when I get this done. So let's find my z-score first. My z-score is going to be 41, subtract 50, divide by 7. Okay, 41 subtract 50, and then divide by 7, and I get this right here, negative 1.285. All right, so my z-score is negative 1.285714, and so on. Okay. All right, we only have 2 digits from the table, so I've got these two. The 5 will make that 8 go up to negative 1.29. So I look this up on the table. So negative 1.2 right here, and I go all the way over here to 9, which is 0.985. So this probability is 0.985. There's my probability for that. But this is to the left, which is less than, and I want greater than. See, this says greater than 41. So I got to do 1 minus that, which is going to be 0.9015. Now notice this is off, this is exact. See, we rounded up here. We rounded this, which is going to make my z-score be off just a slight bit, but it's still going to count this. If you put this in, it'll count it. Okay, now this one, all right, here it says between them, between 72 and 76. So what I'm going to do is I'm going to find these z-scores, I'll find the probabilities, and then I'll subtract the two. Okay, so let's find the z-score of 72. So the z-score, I'm going to put 72 here. Okay, so it's going to be 72 minus, oh, we didn't read it, here's my mean right there, 84, and there's my standard deviation, 5. Okay, so 72 minus 84 equals, divide by 5. All right, it's negative 2.4. So the z-score of 72 is negative 2.4. All right, let's go ahead and do 76. The z-score of 76, it's going to be 76 minus 84 divided by 5. 76 minus 84 divided by 5. You got to make sure you hit equals after you do the subtraction. That's negative 1.6. So that's the z-score of the 76. Okay. So now look these up. So if I look this one up, negative 2.4, negative 2.4, right here, 0082. 0082. There's my probability here. Okay, that's my probability. 72. All right, what's my probability of 76? So look up negative 1.6. Negative 1.6 is right there, 0548. There you go. There's my two probabilities. Now to find between these two, I subtract them. All right, so I'm going to go 0.0548, subtract 0.0082, and I get 0.0466, and there you go. Okay, so there's three ways it could go. Your probability is less than a value, so you look up your z-score, you find that probability, and that's your answer. Or it's greater than a value. So if it's greater than, you look up that z-score, and then you got to do 1 minus that. Or it's going to be between two numbers, which you look up each z-score, find the probabilities, and you subtract them. That's the three ways it could be. So let's look at number 4 here. We got a few problems like number 4. In a recent study on world happiness, participants were asked to evaluate their current lives on a scale of 1 to 10, where 0 represents the worst possible life and 10 represents the best possible life. The responses were normally distributed with a mean of 5.3 and a standard deviation of 2.1. Answer parts A through D below. So in part A, find the probability that a randomly selected study participant's response was less than 4. All right, we're going to find less than 4. So the probability that it's less than 4. Okay, so that means I'm going to do 4 minus the mean, 5.3. And I'm going to divide by the standard deviation, 2.1. Sorry about this interruption. So I'm going to do my x, which is 4, minus the mean, which is the 5.3, and I'm going to divide by the standard deviation. So let's see here. Okay. 4 minus 5.3 equals, divide by 2.1, and that's right here. Negative 0.61904. This is my z-score of 4. I'll put the 4. This is my z-score of 4 right there. So now I look this up on the table. All right, now I just have 2 digits. So it looks like this 9 will make this 1 go up to 2. So 0.62 is what I'm going to look up. So 0.62 is right here. Okay, look again, 0.6012, 2676. So that's my probability. That's my probability that it's less than 4. Okay. And you can see here it's 0.2679. It's a little off because this is exact. We just use the table. We don't have the technology to have it exact, but our answer is going to be good. Okay. Part B. Find the probability that a randomly selected study participant's response was between 4 and 6. So now we've got between. So I look up each one of these, find the probabilities, and subtract them. All right, so we're going to go between 4 and 6. Okay, let's get it on the screen there. All right, so let's do 4. So I'm going to find the z-score of 4. All right, now let's remind ourselves, here's the mean and here's the standard deviation. Okay, so I'm going to do 4 minus 5.3 divided by 2.1. And we actually had done that a while ago. Okay, so that's going to be negative 0.61904. And I look it up. Probability that it's less than 4. It's going to be 0.2676. So there's that probability. That's the probability of 4. Now I got to do 6. So let's find the z-score of 6. It's going to be 6 minus 5.3 divided by 2.1. So here's my x. 6 is my x. There's my mu, and there's my sigma. So now I punch that in. All right, so 6 minus 5.3 equals, divide by 2.1, and that's going to be 0.33333. Okay, that's my z-score, so I looked that up on the table, 0.33. All right, 0.30123 right here. You can see the 3 up here in the top, so 0.33 is 6293. 0.6293. That's the probability that's less than 6. Okay. Now I want between those, so I subtract them. All right, so I'm just going to go 0.6293 subtract 0.2676. All right, so this would be 7.163, and there you go, 0.3617. And you can see it 0.3626, which is close, but it's going to be a little bit off on these, but that is the right answer. All right, now part C here. Find the probability that a randomly selected study participant's response was more than 8. All right, more than 8. All right, remember now, more than 8. I look up on the table and I got to subtract it from 1. So I want more than 8. Probability this. Well, let's find our z-score of 8. So it's going to be 8 minus mu, which is 5.3, divided by standard deviation, which is 2.1. Okay, so more than 8. Let's find the z-score of 8. So it's going to be 8 minus 5.3 equals, and then divide by 2.1, and that's 1.285714, okay? We're going to round this, which is 1.2. The 5 makes the 8 go up to 9. So here's the z-score I'm going to look up. So 1.2 and 9 is clear down here at the end, 9015. That's 1.29, 9015. Okay, now we want more than 8, which means I'm going to take this, I'm going to do 1 minus that, which gives me this, 0.0985. And there's my answer right there. Okay, but you can see it's off just a little bit for what the answer should be, but this is exact. That's if we had got the z-score of this. We rounded it to find the z-score on the table. So it's going to be off just a slight bit. So here's a few more problems like that. Okay, these are all the same kind of thing. Let's do this one right here, number 6. Okay. In recent year, the total scores for a certain standardized test were normally distributed with a mean of 500 and a standard deviation of 10.7. So there's my mean, there's my standard deviation. Okay. Now it says in part A, find the probability that a randomly selected medical student who took the test had a total score that was less than 484. So what's the probability? It's less than 484. That's what we're finding here. Okay, well, let's find my z-score of 484. So I'm going to do 484 minus mean, which is 500, divided by the standard deviation, which is 10.7. Okay, so 484 minus 500 equals, divided by 10.7, and that's going to be negative 1.49, write it out here, negative 1.495327103. Okay, but we're going to round this off because our table, we just have 2 values, so this is all I can keep right here. But this 5 makes that 9 go up to 10, which makes the 4 go up to 5. So there's my z-score, 484. Okay, now look that up on the table. So negative 1.50, negative 1.50 right there, 0.0668. And that's my probability. It says less than, which is to the left. So that's 0.0668, which you can see we're right there on it. Okay. Part B right here. Find the probability that a randomly selected medical student who took the test had a total score that was between, all right, so we're between 498 and 513. Okay, so to do this, I've got to do z-scores or both of those. So my z-score for 498 is going to be 498 minus the mean, which was 500, divided by standard deviation, which was 10.7. Okay, here my z-score for 513 is going to be 513 minus 500 divided by 10.7. So I got to type both these in the calculator. So typing this one first, 498 minus 500, enter, divide by 10.7. And I get negative 1.1869. Okay, there's my z-score for that one. All right, now let's find the z-score here. So I'm going to do 513 minus 500, and then divide by 10.7. And I get this right here, 1.2149. Okay, there's my z-score here. All right, now let's look up these z-scores on the table. Okay, now I think this was negative, right? So negative 0.18, this 6 makes the 8 go up to 9, so negative 0.19 is what I'm going to look up. Negative 0.1, there's negative 0.1, and 9 is the very end right here. 4247. All right, this is what I get from the table. So that's my probability, 498. Okay, now what's my probability for 513? Well, I look up this z-score, which is a 1.21. The 4 does not make the 1 go up, so I'm going to look up 1.21. All right, so 1.21 is right here, 0.8869. And there's my probability of that one. All right, well, what's the probability that's between those two? Well, I subtract these. So I'm just going to do 0.8869 69, subtract 0.4247. This is 2, 2, 6, 4. 4622. Okay, I'm not keeping it in the screen very good, am I? So you can see we're right there on it, 4619, 4622 is pretty close. Okay, in part C, find the probability that a randomly selected medical student who took the test had a total score that was more than 528. All right, now remember more, you got to find the probability and subtract it from 1. All right, so probably that's greater than 528. All right, so that means I need to find my z-score of 528, which is going to be 528 minus the mean divided by the standard deviation. Okay, so I'm going to have 528 minus 500 divided by 10.7, and there you go, there's my z-score. Negative 0.1869, which the 6 makes the 8 go up to 9, so 0.19. This is what I'm going to look up. Negative. Lift my negative out. Negative 0.19. .1 4247 right here. See, negative 0.194247. Okay, so that's the probability of 528. That's less than, though. We want greater than, so I have to do 1 minus that for greater than, which is going to be 0.5753. And there you go, 5753. And we didn't get something right here. Okay, this was not negative. I don't know how I got a negative right there. Yeah, we did something wrong here. All right, this is, do this again. 528 minus 500, and then divide by 10.7. Yeah, I hit something wrong there. So 0.2616. See, I did it right this time. So this would be 2.616. 2.616. So I look up this z-score, which would be 2.62. Okay. 2.62 is right there, 9956. 0.9956. All right, so I got to do 1 minus that, which is 0.0044. So there's my answer. This is wrong. And there you go. We got it right. It's exactly right. All right. So now this part D says identify any unusual events. All right. Now remember, to be unusual, it has to be less than 0.05. So if it's your probability is less than this, that's unusual, which that's what this one is here that we just did. Let's see. So here's the first one. That's not unusual. It's close. Here's the second one we did, and that's not unusual. But this last one, now that's unusual. So the C is, so the answer would be here, part C. That's unusual because it's less than 0.05. Okay. So we have another one like that, and then here's the same thing. Let me go through one of these. Assume a member is selected at random from the population represented by the graph. So you have this graph right here. Find the probability that the member selected at random is from the shaded area of the graph. So this shaded area looks like it's between 200 and 375. All right, so we're just going to do the same thing we just done the last few times. We're going to find the z-score of both of those and subtract them. So between 200 and 375. Now here's my information I need right there. There's my mean and my standard deviation. So what's the z-score of 200? All right, so it's going to be 200 minus 501 divided by 115. What's the z-score of 375? Well, it's going to be 375 minus 501 divided by 115. Okay, so if I do this one, 200 minus 501 equals divide by 115. I get there negative 2.6. I'm going to go ahead and round it. 7 makes the 1 go up to a 2, so negative 2.62. That's the z-score of 200. Okay. Now, what's my z-score over here at 375? So I'm going to do 375 minus 501 divide by 115. And I'm going to go ahead and round it. That 5 makes the 9 go up to a 10, so it's negative 1.10. That's my z-score there. So I look these up on the table. All right, negative 2.62, negative 2.6 is right there. 0.12 right there, 0.0044. That's my probability that they're less than 200. All right, look this up on the table. Negative 1.10. Negative 1.10 is 1357. So that's the probability that it's less than 375. Now to be between those, I subtract them. So 0.1357 subtract 0.0044. It's going to be 3131. 0.1313. Okay, which you can see here, got 0.1322, which we're right on it. And so that's what we do here, same thing. Okay, find the z-scores, subtract them. That's what we'll do here, and that's similar to what we'll do down here on these. All right, so I think that's about it. We're going to close up shop. Well, but that's how we do our z-scores, find our probabilities and normal distribution. So if you have any questions, contact me. I'll try to help you all I can. Have a good rest of the day.